Hello students, today in this video we are going to see about homoaromaticity. Okay, so before moving on to the homoaromaticity, what is the nature of this compound? It is nothing but cyclooctatetraene, okay, because it has 8 carbon atoms, hence it is known as octa, and 4 double bonds, and it is tetraene. So since it is cyclic in nature, it is known as cyclooctatetraene. Okay, here all the carbon atoms are sp2 hybridized. It is cyclic in nature. It has conjugation of pi electrons. So you may think like 2, 4, 6, 8. So there are 8 pi electrons. It is multiple of 4. That is 4n pi electrons. Hence this particular compound will be anti-aromatic. Right? But if you think like this, it is wrong. Okay, it is not so. This compound is non-aromatic. This compound is non-aromatic. See, cyclooctatetraene actually, it will exist like tub-shaped. Okay, it is tub-shaped molecule. These two are projecting out of the plane. This non-planar, right? This non-planar. These two are not in the plane. Others are in the plane, but these two are projecting outwards, right? It is out of the plane. Hence, it is non-planar. If the compound is non-planar, then that particular compound will be non-aromatic, right? Hence, cyclooctatetraene is non-aromatic and it is not anti-aromatic. This is one exceptional case, okay? It has been asked in CSIR NET. So, we are going to study the aromaticity concept in the cyclooctatetraene. I have already told you that cyclooctatetraene is non-aromatic in nature, but it can act as homoaromatic compound. Suppose if I am adding H+, right? H+, it is an acid. See, this pi bond can be shifted, right? Suppose if it's shifted like this, then you will have minus here and plus here. And the others will be like this. If I am adding this H+, okay, now I am adding H+. It will go and attack here, right? Because it possesses positive charge, it will attack negative charge. So, what you will get? You will get like this. Here, you are having sp3 hybridized carbon atom, right? sp3 hybridized carbon atom. How I am saying that it is sp3 hybridized carbon atom? Because count the number of sigma bonds. Here it is for this carbon atom. For this carbon atom, 1, 2, 3, 4. Since this carbon atom possesses 4 sigma bonds, it is said to be sp3 hybridized carbon atom. Okay. We have already studied that if we have sp3 hybridized carbon atom, then that particular compound will be non-aromatic in nature. But here, see, this sp3 hybridized carbon atom, except this sp3 hybridized carbon atom, remove this carbon atom and see the other 7 carbon atoms. It is nothing but a tropylium carbocation, right? These are tropylium carbocation. If you remove the CH3 hybridized carbon atom, if you remove this sp3 hybridized carbon atom, and the remaining portion will be this tropylium cation. This tropylium cation is already aromatic in nature. We have studied, right? So, what is this type of aromaticity is known as homoaromatic, okay? Because it possesses one sp3 hybridized carbon atom. Even though it possesses sp3 hybridized carbon atom, it is also exhibiting aromaticity. The remaining carbon atoms, except that sp3 hybridized carbon atom, the remaining portion will exhibit aromaticity, right? Hence, this particular concept is known as homoaromaticity. Okay? What is the definition for homoaromaticity? Is nothing but if a stabilized cyclic conjugated system can be formed by passing one saturated atom. What is saturated atom? It is sp3 hybridized atom. Then that particular compound will be said to be aromatic, homoaromatic compound. Okay, that is here CH2, here one positive charge. It is sp3 hybridized carbon atom, but these belongs to cyclic stabilized conjugated system. Okay, now this cyclooctatetraene having one sp3 hybridized carbon atom can be drawn like this. This sp3 hybridized carbon atom moves out of the plane. Okay, it goes out of the plane. So now in the plane it has only 7 carbon atoms, and out of 7 carbon atoms, all the 7 carbon atoms are planar. See here, this carbon, these 2 carbon having double bond, so it is sp2 hybridized. Similarly, these 2 sp2 hybridized, and similarly these 2 sp2 hybridized. So here carbocation, obviously it is also sp2 hybridized. So all the carbon atoms are sp2 hybridized means it is planar. It has conjugated system also. Double bond, single bond, double bond, single bond, double bond. And it is possessing a positive charge, right? Hence, this system is aromatic. This is similar to that of the tropylium carbocation. 7 carbon atom, 3 double bond, 1 positive charge. So, if you remove this sp3 hybridized carbon atom, this system is aromatic. But if you have this sp3 hybridized carbon atom, hence it is said to be homoaromatic compound. Okay, this is said to be homoaromatic compound. So, homoaromaticity is nothing but you will have sp3 hybridized carbon atom also. But if you remove that sp3 hybridized carbon atom, the remaining system will be aromatic in nature. That is known as homoaromaticity. Okay. Let me give you another example so that you will be clear with the concept. Here, in the system, this particular carbon atom is having an sp3 hybrid, right? The system is having sp3 hybridized carbon atom. So what will you say? Since it possesses sp3 hybridized atom, this particular compound is said to be non-aromatic, but it is not so. If you take this atom or you move this atom out of the plane, okay? See, these are in the plane. This particular carbon atom is out of the plane. It is out of the plane. Okay. sp3 hybridized carbon atom moves out of the plane. So the remaining, see the remaining there are 3 carbon atoms, right? Remove this. See the remaining 1, 2, 3 carbon atoms. All are sp2 hybridized, right? Actually, it is similar to that of your cyclopropenyl carbocation. 3 carbon atoms possessing 1 double bond and 1 positive charge. So this is homoaromatic. Okay. sp3 hybridized carbon atom moves out of the plane. The remaining, see, all the carbon atoms are sp2 hybridized. It is planar. Hence, the particular compound should be aromatic. Since it possesses 2 pi electrons, it should be aromatic. But since we are having sp3 hybridized carbon atom also, this is said to be homoaromatic. Okay, homoaromatic. Now we are going to see about quasi-aromatic compounds. So what are quasi-aromatic compounds? It is very simple, okay? Very simple concept. They will provide you examples like this. Quasi-aromatic compounds exhibits high dipole moment. Okay, high dipole moment. What is dipole moment? It's nothing but charge separation, right? So here carbon double bond oxygen. Which is more electronegative here? Oxygen, right? So you have to shift the bond towards itself, because always oxygen tries to pull the electron towards itself because of its high electronegativity. So this bond will be like this, right? Now just see the ring. You have to see the aromaticity for the ring. Now see the ring. It is nothing but a cyclopropenyl cation, right? It is cyclic in nature. It is planar and then see the number of pi electrons. It possesses one double bond, which means 2 pi electrons. Hence, this compound is aromatic in nature. That's it. It is very simple concept for quasi-aromatic. Okay. Just shift the bond towards the most electronegative atom, so that you will get another structure. For that structure, you just see the aromatic nature. Okay. Similarly, just do this for the second compound. Okay. For the second compound, how will you break this bond? Again, O minus, and this is positive because it will shift like this. Now see the ring. It is cyclic in nature. Then it is planar. Then now count the number of pi electrons. It is 2 pi, 4 pi. So you have 4 pi electrons. If it comes like 4 pi electrons multiples of 4, then it is anti-aromatic, right? Anti-aromatic. I hope this concept will be clear for you. Quasi-aromatic is very simple. They will provide you like a carbonyl group. You just shift the bond towards the most electronegative atom, and after charge separation, see the ring and count the number of pi electrons. Okay. That's it about quasi-aromatic compounds.